Today we're going to talk about solving rational equations. By the end of this video, you should be able to use the LCD to solve rational equations and check for extraneous solutions. So, to solve a rational equation, there are 5 steps that you should follow. First, you need to find the LCD. And we'll do this just like we did when we did addition and subtraction. Next, you need to state the domain. And again, this is the same thing that we did with addition and subtraction. You use the LCD to help you figure out the domain. Step 3, you need to multiply all the terms of the equation by the LCD. This will help you cancel out the denominators. If you have done this step correctly, you should no longer have any fractions or rational expressions in your equation. Step 4 is to solve the resulting equation. This equation could be a linear equation or a quadratic equation, so you might have to factor. And the last step is to check for extraneous solutions. You should remember from earlier in the year that extraneous solutions are extra solutions. You do all the math correctly and you end up with this extra answer that does not work. To check for extraneous solutions in rational equations, you just need to compare your answers with the domain restrictions. So let's look at a couple of examples. First, we have 9 over 10 plus 2 over x plus 1 equals 2/5. So our first step is to find the LCD. So we know that we need an x plus 1 in our LCD. Then we have 10 and 5 as the other denominators. Since 5 is a factor of 10, our LCD is 10 times x plus 1. Then we need to find the domain. And we'll do this just like we did in previous tutorials, where you set the LCD equal to 0 and solve for x. So if we set x plus 1 equal to 0 and solve, we end up with x cannot equal -1. So now, step 3 is to multiply every term of this equation by the LCD. So I need to multiply each fraction by the LCD. Then we cancel. So in the first fraction, the 10s cancel, and we're left with 9 times x plus 1. In the second fraction, the x plus 1s cancel, so we're left with 2 times 10. And in the third fraction, we can simplify 10 over 5. So we're left with 2 times 2 x plus 1. So now we just need to solve this equation. So if I distribute, and multiply. Then I can combine my like terms. Move all my x's to the left side of the equation. Subtract 29 from both sides. And then divide by 5. Now, to check for extraneous solutions, I need to compare my answer, which is x equals -5, with our domain restriction. Our domain is that x can be anything except -1. So as long as my answer is not -1, it is not extraneous. So x equals -5 is our answer. Let's try number 2. As we discussed with adding and subtracting, you should always factor the denominators. So x squared minus 4 factors to x plus 2, x minus 2. That will help us find our LCD. So our LCD will be x plus 2, x minus 2. Then to find the domain, if we set the LCD equal to 0, we get x such that x does not equal positive or -2. So now we need to multiply our equation by the LCD. Then our denominators should cancel. So in the first fraction, both the x plus 2 and the x minus 2 cancel, leaving us with just 2x plus 4. And on the right side of the equation, the x minus 2's cancel. So we're left with x plus 4 times x plus 2. Now, to solve, I need to multiply out the right side of the equation. Since I have an x squared, this is a quadratic, so I need to set it equal to 0 and solve. Now I need to factor. Then I can go ahead and solve, and I get x equals -2. So now I need to compare my answer with the domain. The domain is that x can equal everything except positive or -2. So that means that -2 will not work, because that will make us divide by 0, which is not allowed. So since we are not left with any solutions that work, our final answer is no solution. We have x plus 12 over x equals 8. So our LCD is just x. And if we set that equal to 0 and solve for our domain, we end up with x cannot equal 0. So now we need to multiply every term by x. So we have x times x, which is x squared. Then in the second term, the x's cancel. And then we end up with 8 times x on the other side of the equation. So again, we have a quadratic. So we need to set it equal to 0 and factor. Then we end up with x equals 6 and x equals 2. When we compare these with our domain, we said that x could be anything except 0. So both 6 and 2 work. For number 4, let's start off by factoring the denominators. So I can factor out an x. Then we need to find our LCD, which is x times x minus 1. So if we set that equal to 0 and solve, our domain is x cannot equal 0 or 1. So now we need to multiply each term by the LCD. So on the left side, both the x and the x minus 1 cancel out, so we're just left with 2. And on the right side, the x minus 1's cancel out, so we're left with 1 times x, which is just x. There's nothing left to solve here, so now we need to just compare this with our domain. We said x could be anything except 0 or 1, so x equals 2 works. For number 5, we don't need to factor any of the denominators because they're all linear, so we just need to go ahead and find the LCD. And that'll be x times x minus 3. Then if we set that equal to 0 and solve, we get that our domain can be anything except 0 or 3. Now, if we multiply all of our terms by the LCD, then we need to cancel. In the first fraction, the x minus 3's cancel, so we're left with 2 times x, which is 2x. The second fraction, the x's cancel, so we're left with 1 times x minus 3, which is just x minus 3. Then on the right side, the x minus 3's cancel, so we're left with x times x minus 1. So now we can go ahead and combine our like terms on the left and distribute on the right. So we have 3x minus 3 equals x squared minus x. So we're going to end up with a quadratic, so we need to set it equal to 0 and then factor. Then if we factor, we end up with x minus 3 times x minus 1. So our answers are x equals 3 and x equals 1. Now we need to compare with our domain. We said x cannot be 0 or 3. So that means 3 does not work, but 1 does. So our answer is just x equals 1. Let's look at one more example. Again, we need to start by factoring the denominators. So I can factor out an a here. Then if we find our LCD, that'll be a times a minus 7. If we set that equal to 0 and solve, we get that a cannot equal 0 or 7. Now we need to multiply each fraction by the LCD. Then we can cancel. A minus 7's cancel in the first fraction, so we're left with 6 times a. The a and a minus 7 cancel in the second fraction, so we're just left with a minus 49. And in the third fraction, the a's cancel, so we're left with 1 times a minus 7. So now we can go ahead and combine our like terms. We can subtract 2a from both sides, and then divide by 4. So we get a equals negative 14. If we compare this with our domain, that works.